Hello everyone, welcome to another build guide by rcprinter.com. Today we're building this awesome open source Tarmo4 3D printable RC car. So first we have to say a big thank you to Engineering Nonsense for the freely shared designs for this bad boy, as well as the previous few versions of the open source Tarmo cars and the upcoming Tarmo 5. Also, a big thanks to for a cool username on Reddit for an awesome build guide that helped immensely in the making of this video. One last thing before we get started, if you're looking for ideas of cool RC projects to build, guides on how to build them, kits, parts, or more, check us out at rcprinter.com.
rcprinter.com.
Alright, so first we're going to start with building the basic chassis, which consists of three parts. One 2A, which is the center chassis, and two 1As, which are the end chassis. You're just going to simply bolt those together with four M3x16 screws and M3 lock nuts. Once that's complete, you're going to strengthen it all with two pieces of M4 threaded rod, which you can screw together with M4 lock nuts. I found that if I put the threaded rod into the chuck of my screw gun, it was really easy to cinch everything up. Once it's all tight, you can trim the excess with a Dremel or saw. Next, we're going to install the battery mounts, which are two of parts 4A. These just attach with four M4x10 screws threaded through the bottom. Next, we're going to add part 7B, the gearbox case. Installation is pretty simple here as well, as you just screw from underneath the frame with four M4x20mm screws. Orientation of the gearbox does matter, so make sure the side with the extra tab goes on the left side of the vehicle, as that is where we're going to mount the servo. Now we're going to add part 5A, the steering mount. This part has recesses for M3 lock nuts, so first press those into the two holes closest to the center as best as you can. And then attach the steering mount to the chassis with two M3x25mm screws from underneath. When you tighten the screws, they'll pull the lock nuts the rest of the way into their holes. Now we're going to add the front and rear diff gearbox cases, which are two of the exact same parts 3A, and they get attached to the front and rear of the chassis with four M4x10mm screws. Underneath each case, though, is a different suspension arm mount. 15A is the suspension arm mount for the front, which we're doing first here, and you can tell it apart because the suspension arm mounts are tilted up slightly towards the front of the vehicle. Then you can do the back with part 18A underneath the gearbox case, which has horizontal suspension arm mounts. Next, we're going to add the motor output gear part 9A. Slide on two of the 10x15x4mm bearings and drop it into the big central spot in the gearbox. The gear is asymmetrically located in the box, and it should be oriented so that the gear is closer to the front of the gearbox. Now we're going to add your motor. The specs call for a brushless D3542 outrunner motor, which is exactly what we're installing here. First, you'll need something to connect the motor drive shaft to the 9B input gear. The specs call for using an HSP 08065 metal wheel hex, which I'm certain I ordered, but I couldn't seem to find it anywhere, so instead I went the alternate route and printed a motor shaft adapter from Thingiverse, which you can see me screwing on right now. I'll leave a link in the video description to the part I used. Then you're going to push the input gear, part 9B, onto your adapter. Push hard and make sure it seats fully all the way down. Next, we're going to add some bearings to the diff gearbox. I didn't catch it on camera, but you need to add one 10 by 15 by 4 millimeter bearing to each of the drive shaft sides of the gearboxes, and then another inside each of the gearboxes. Then you can add the diff input gears, part 13B. Then you can finagle in the two flexible TPU drive shafts, part 10B. To do this, you may need to pop out the main output gear, as I did. Now add a bearing to the end of your input gear and secure the motor to the motor mount, part 8Z, with either the screws that came with your motor or ones of an appropriate size for the motor you bought. I oriented my motor wires facing up and to the outside a bit, and I didn't have any issues with that. Next, slide your motor into place and then secure it to the main chassis plate with two M3 lock nuts and M3 by 12 millimeter screws. Make sure everything moves smoothly, and then add some super lube or another PTFE based lube. At this point, the main gearbox is complete, so you can go ahead and attach the gearbox case with two M4 by 20 millimeter screws. Alright, now we're going to go ahead and work on finishing up the rear differential, which is a locked differential. Grab your lock diff gear part 13A and put two of the bigger 15 by 24 by 5 millimeter bearings on each end and drop it into place. Now lube your gears. Push on the gear to make sure it seats nicely. It doesn't really matter which way it goes as far as I know, it just needs to be opposite the front gear, which we'll do next. Then we'll attach the diff gearbox lid. It's symmetrical, so either way will work, and then you secure it with four M3 by 12 millimeter screws. At this point, you can also attach two of the bell housings, 13C, to the rear diff. Okay, so now we're going to do the front open diff, which is a little more complicated. This section requires a Traxxas 5382X diff gear set, so go ahead and open that and get it ready. You're going to go ahead and take one of the open diff bell housings, part 14C, and add one of the larger 15 by 24 by 5 millimeter bearings on it. Then add piece 14B to it. 14A would work too, doesn't matter which one. Then drop one of the metal gears that has a shaft with a hole in it from the metal Traxxas gear set into part 14B, shaft first, and use a short length of wire, I actually used a paper clip, through the tiny hole in the side of the open diff bell housing and out the other side, catching the Traxxas gear in the middle. Bend at the end so it doesn't move much. Then you're going to do the exact same thing with the other diff bell housing and 14A and a shafted Traxxas gear and another bearing and another paper clip. Then you're going to drop the rest of the metal Traxxas gears into the diff with the capital I piece in the middle and the shaft running through them all. They'll only fit in there one way. Then you're going to push the two halves together and voila, you've made a diff. Then, to finish it off, remove any excess wire, leaving maybe 5 millimeters or so on each side. Slide it into the diff housing and then lube your gears. One note here is to make sure to orient the gear to the opposite side of the vehicle as the locked diff in the rear, so the wheels aren't trying to spin different directions. I've actually messed that up, and now I'm going to have to go back later, once the camera's off, and switch that. Finally, attach a diff gearbox lid with four M3 by 12 millimeter screws. Okay, that's probably the hardest part of the build out of the way. Now let's work on the suspension mounts, parts 16A and 19A. The one for the front, 19A, is angled slightly, and they each screw right into the diff gearboxes with 3 M3 by 12mm screws. Easy peasy. Now we can tackle the servo. Grab the servo mount 7C. Mount the servo to the servo mount with 4 M3 by 12mm screws. Two of those screws are going to tighten into the main gearbox, and you can reach them with a hex driver through conveniently located holes in the side of the chassis. And then you can secure the mount to the chassis plate with an M3 by 12mm screw from underneath and an M3 lock nut on top as shown. Use the screw to pull the nut into place. Now we're on to the rear suspension. Take a 17A lower control arm and secure it to the support with a M4 by 35mm screw, not too tight as you need it to pivot. Add a rear knuckle 15B with another M4 by 35mm screw. Now do the same thing to the other side. Now you can slide some bearings and bell housings into the knuckles if you'd like. And then we can go ahead and make 2 dog bones out of printed pieces 12A by threading an M3 by 16mm screw through each end and securing with an M3 lock nut. You should probably cut off any excess, but I was lazy and it seemed to work fine. Your mileage may vary. Next, you can slide an M4 by 35mm hex head bolt into each bell housing 13C, and then you can put the dog bones in place. Now you're going to add in the upper control arms, part 16B. Take one M4 by 35mm screw to secure the upper arm to the knuckle, and again, not too tight as it needs to pivot, and then add a second screw to tie the upper arm to the lowest hole in the shock tower. Again, not too tight. Same thing for the other side. Press fit a bearing onto the outside of each bell housing. And then just make sure everything moves freely. Then you're going to add your shocks with M3 screws of whatever length works for the shocks you bought. 16mm worked well for me. Okay, congrats, your back end is now complete. Let's do the front. Take a lower control arm 17A and attach it to the support with an M4 by 35mm screw. Then, grab a steering knuckle mount, part 18B, and secure it to the lower control arm with 2 M4 by 10 screws. Then do the same thing on the other side. Slide an M4 by 35mm hex head bolt into each wheel axle, and then go and make 2 more dog bones using M3 by 16 screws and nuts, just like we did for the back. Then add a 10 by 15 by 4mm bearing onto the shaft of the wheel axle and slide it into a steering knuckle part 18C. Then add another bearing on the outside of the steering knuckle and press it into place. As you can see, mine were a bit tight and took a little finagling to get them into the right spot. Attach the steering knuckle to the steering knuckle mount with two M3 by 12mm screws, not too tight as the steering needs to steer. Make sure the arm of the steering knuckle is facing the middle of the vehicle. Now do the other side. And slide your dog bones into place. Now add your upper front control arms, parts 19B. Two M3 by 12 screws will screw it to the knuckle, and then M3 by 25 screws will secure them to the lowest hole on the shock tower. Hey dude, I said the lowest hole in the shock tower. Then you can add your shocks with some M3 screws. I found on the first go around that mine didn't want to fit so nicely at the top, so I ended up using two M3 non-locking nuts on some slightly longer top screws to give it a little room to flex. Do a quick check to make sure everything's moving nicely. Next we're going to do the steering. For the steering you're going to need to start with printed parts 20, A, B, and C, the steering center link and arms. There are many ways you can do this, but I decided to screw the three parts together with two M3 by 12 screws and then slide them underneath the front drive shaft. Took a little bit of shimmying, but it wasn't too hard. You can also try sliding them in place and then screwing them together from there, but it might get kind of awkward. Once connected and in place, you can attach the steering assembly to the steering bracket from underneath with two M3 by 25mm screws and lock nuts. Next, you can add the two steering links, which look the same but are actually opposite. When installed, they should slope towards the back of the car slightly. Attach them with two M3 by 16mm screws to the steering knuckle and to the center link. You can now see how by moving the master steering arm, the wheels will turn. Okay, we're almost there with the steering. Next we're going to be hooking the servo up with the master steering arm. The first step of that is to make sure your servo is centered, which I've already done off camera. You do that by powering it up by connecting your battery to your ESC to the radio, and the radio to the servo. The next thing we're going to do is install the servo horn, which is made easier with the access hole in the side of the chassis. Make sure it's pointed straight up, and you'll probably need a Phillips screwdriver and maybe some Allen keys. Then you're going to get an M3 rod end and thread some M3 rod into it as far as it'll go. I drew a line on the rod just to help me estimate how far it actually goes in. Then you're going to temporarily install the rod end with an M3 by 12 screw driven into the master steering arm, so we're going to know its exact location. Then estimate the length of the rod you're going to need to make it to the servo and slide an M3 nut down the rod past the length you're going to cut. Attach a rod end to the servo so you can see exactly where you need to cut it. Then cut your rod. Unthread the nut from the rod a few times to fix any threads that may have bent over, and then screw on the other rod end. Reattach the rod ends to your new servo link arm with M3 screws to the servo horn and the master steering arm. Voila, you now have steering. Next, we can go ahead and add some wheels. I had some old Traxxas Slash wheels lying around, so I decided to use them for this. They worked, but the hex hubs are quite inset on them, so it only cleared the steering arms by about 1 mm. They're pretty easy to install with the printed 11A wheel adapters, and each just gets a 4 mm lock nut. If you're using 3D printed wheels, you may not need the adapters. Now we're going to add the electronics. I put my ESC on top of the servo bracket and the radio receiver on top of the gearbox, and that seemed to work well. I've attached them with double-sided Velcro tape temporarily here, so they wiggle a bit. In the future, if I keep this orientation, I'll likely attach them with something a little more permanent. Connect your motor wires to your ESC according to their instructions. Connect your servo to your receiver, likely in channel 1, and your ESC to your receiver, likely in channel 2. Now we need some power. Throw your battery into your battery box and attach it to the box base with 4 M3x12 screws. A 3S battery would probably be the best, but I'm just going to use a 2S battery for now, just for testing. Then mount the battery box onto the brackets by sliding it backwards into the grooves and then securing with 2 M4x12mm screws. Alright, now it's time to power it up and see if everything works. Connect your battery to your ESC, turn on your radio, and then turn on your ESC power switch. Check the steering. Check the drive, and shut it back off. Congratulations, you've built your first Tarmo4. Now as an added bonus, we're going to show you how to add a rear wing and skull cover to give it that classic Tarmo look. If your rear wing printed in 2 parts, attach it together first with some CA glue. I like to clamp it together just to make sure it's a nice good bond. Set it aside to dry. Attach the rear wing and body holder with 2 M3 screws, approximately 25mm in length. Remove the battery box and attach the front skull support by removing the 3 screws that hold the shock tower in place and replace them with longer M3 screws, about 16mm long. Honestly, this was probably the most tedious part of the whole process. Attach the rear wing with M4 by 12mm screws and the printed washers provided. Put the skull in place and mark some holes for where it's going to mount. Drill the holes and then install it in place with two M4 by 16mm screws and washers at the front. The rear skull mount is supposed to be held in place with a body clip, but mine didn't print great and ended up snapping off, so I drilled out a hole size for an M3 screw for now. And here is the finished Tarmo4 in all its glory. And here's our first test run. More of that next time on rcprinter.com.